Welcome to Lesson 7 of the Rust Ownership Series, Introduction to Lifetimes. We've seen how ownership and borrowing rules work. The borrow checker is the compile time guardian that ensures these rules are followed. But there's one crucial question. How does the compiler know the validity of a reference? The simple answer is a core Rust concept: lifetimes. So, what is a lifetime? A lifetime is a construct the compiler uses to ensure a reference is valid for a specific scope. Every reference in Rust has a lifetime, but most of the time, we don't have to write them out. The main goal of lifetimes is to prevent a very specific and dangerous problem: dangling references. Let's visualize this. Imagine we have an outer scope. Inside it, we declare a reference, R. Now, a new inner scope is created, and inside it, the value X is created. Our reference, R, borrows X. So far, so good. But what happens when that inner scope ends? The memory for X is deallocated. It no longer exists. But R, which lives in the outer scope, is now pointing to invalid, deallocated memory. This is a dangling reference, and it's a source of major bugs in other languages. Lifetimes are how Rust prevents this at compile time. Rust's borrow checker uses lifetimes to analyze the code and ensure that references are always valid before the program is even compiled. It would see the situation and refuse to compile, saving us from the bug. Now, you might be thinking, I've written code with references, but I've never typed a lifetime. That's because most of the time, the process is automatic. The compiler can usually infer the lifetimes for us based on common, predictable patterns. This powerful feature is called lifetime elision. Sometimes, however, the compiler's rules aren't enough and we need to be explicit. Let's look at a common example: a function that takes two string slices and returns the longest one. Here we have fn longest of a, x is reference a of str, y is reference a of str, and it returns a reference a of str. This a syntax, the tick a, is a lifetime annotation. It's telling the compiler for some lifetime, which we'll call a, our parameters x and y must both live at least as long as a. And the reference we return will also live at least as long as a. In practice, this means the lifetime of the returned reference is tied to the smaller of the lifetimes of the inputs. This prevents us from, for example, returning a reference to x if x is about to go out of scope, while y lives on. It's important to remember these annotations don't change how long any of the values live. They are purely compile time tools. You are simply describing the relationships between the lifetimes to the compiler so that it can verify your code is safe. So let's summarize. Lifetimes are a compile time tool to ensure all references are valid. Their primary goal is to prevent dangling references. In most common cases, the compiler infers them automatically through lifetime elision. But in complex cases, we need to add explicit annotations to describe the relationships between references. Lifetimes are the final piece of the puzzle. Ownership, borrowing, and lifetimes all work together to provide Rust's core promise: fearless concurrency and memory safety, all without a garbage collector. In our next lesson, we'll dive deeper into exactly when and how to use lifetime annotations in functions.